Welcome to Future Forward, a podcast where we share AI insights, one expert at a time. I'll be talking to experts from various backgrounds, ranging from academia to startups, scale-ups, and corporates. Welcome. Hi there, I'm Davio, your host for today. I'm the CEO at Radix, and I'm here with Laurent Sorber, the co-founder and CTO at Radix and co-founder and CTO at InvestSuite. Hi there, how are you?
Hi, thank you for having me.
You're welcome. We've been working together for a few years so far, but first, I know your history quite well, but maybe talk a bit about it. You have done a PhD, you've been working in a few startups, you've been working at a bank. Maybe you can tell us a bit more about your background.
Yeah, sure. So I studied mathematical engineering at KU Leuven here in Belgium. And after that, I did a PhD on the topic of tensors and tensor decompositions. And after
Which is also in a more fancy name, data fusion, if I recall well.
I researched indeed methods to fuse several data sources, each data source represented as a tensor, where a tensor is basically a multidimensional array of numbers.
Which is quite technical.
Yes. So just imagine...
It's similar to like multimodality today. Can you compare that?
It is similar to multimodality. Essentially, all data is essentially represented as numbers, and usually those numbers are represented in a matrix, or more generally in a multidimensional array. For example, an image you could think of it as a 3D array of numbers, and a video potentially as a 4D array of numbers, where you have X and Y, and you have the color dimension, but you also have the time dimension. But data in general, we tend to represent it as matrices or tensors in general. And the idea of data fusion then is to see if we can extract information from multiple sources that are linked with each other. For example, a classic case is where you have information about users and information about user preferences. And those are two separate data sources. And perhaps you can use those or combine those to make even more powerful predictions about those user preferences.
Which is something we're seeing in the multimodal evolution today, which is combining mainly today images and text, basically.
Yes, although I would say the current way that we're exploring multimodal is a bit different from how I did it in my PhD.
Okay.
So after my PhD, I joined KBC Group and helped to build their data lab. Did that for a few years, and then I left KBC and did some freelancing in machine learning. And that eventually then led to co-founding Radix, as you said.
You met me.
I met you. And also co-founding InvestSuite. So,
and today you're a CTO at both companies. Can you sketch a little bit what you're doing at both?
Yeah, sure. So Radix is essentially an AI services company, whereas InvestSuite is a fintech product company. So they're, I would say, on two opposite ends of a spectrum. At Radix, as you know, we develop custom AI solutions for our clients. We do that across multiple industries and across multiple AI domains. And at InvestSuite, we're developing a suite of products, hence the name InvestSuite, that all are in line with essentially helping to bring investment solutions to a wider audience of people. So essentially attempting to democratize investing.
Wealth management.
Wealth management, but various products within the space of investing. So either investing yourself or having an autopilot invested for you, helping to explain your investments performance in a human way.
All right. And in both you're using AI. Can you tell us a bit more about what you're doing with AI, for instance, at InvestSuite and then at Radix?
So we use AI at Radix for, as I mentioned, across several industries, but also across several AI domains. So the use cases are really very broad. These days, there's a lot of interest on large language models. Just because their capabilities are so surprising and so powerful. And the same, I would say, is true at InvestSuite, where we're also exploring using large language models to enhance our existing products.
And can you elaborate a bit on that, or is that trade secret so far, for now?
Do you mean at Radix or at InvestSuite?
At InvestSuite.
At InvestSuite, so one product at InvestSuite is called Storyteller, and Storyteller tells you the performance, tells you the story of your investment portfolio's performance. So let's say last year, what happened to your portfolio? That story is AI generated, and of course, it would make sense to explore how to use large language models to enhance that storytelling. For various reasons, you can't just have the large language model directly generate the story, because then the bank or the financial institution wouldn't be in control of what exactly is being said. But we're exploring other opportunities there. For example, once you've selected which news articles might help to explain your portfolio's performance, you could use a large language model to explain why or how exactly that news article impacted your portfolio's performance, instead of you having to actually read the news article.
Mm-hmm. That's really interesting. And so how did it change? Because at Radix, we supported InvestSuite in Storyteller. It was like, if we would do it now, probably compared to when we started with Storyteller, it's a huge difference. In technology, would it be different today? It's now large language models have made a huge jump, whereas when Storyteller started, that wasn't the case. If you would do it again, would that be very different?
So when we collaborated, we actually worked on a different topic, which is selecting which news articles might be the most relevant or the most impactful to explain that portfolio's performance. That wouldn't necessarily be very different, I would say. There are some things we could do with large language models that would help to improve the selection there as well. For example, we could use large language models to automatically categorize which regions or which sectors the news article is relevant for. And that information can then be used to help select the most relevant news articles. So there are definitely opportunities in the selection itself, but I see more opportunities in the actual explaining of why that news article might be relevant. And that wasn't possible at the time that we collaborated, yes.
Mm-hmm. So at Radix, we're basically a partner for our companies, for our ambitious clients, to help them in their AI journey. We're doing this for 5 years. How have you seen that change? So I remember when we started 5 years ago, one of our major projects was helping VDAB at that point, which was a huge work to do matching of jobs and profiles. Looking at it today, we would probably do it entirely differently. But also in terms of companies having changed in their maturity, whereas when we started, the ITers, the technical people knew a bit about AI, but even that, now everybody talks about AI and wants AI. How have you experienced that? What's most striking to you in those 5 years?
What strikes me is definitely an evolution from narrow AI to a broader version of AI now with large language models. Initially, all AI that we developed, you could classify as narrow AI, meaning that the AI solutions we develop, they are built to solve a very narrowly defined task. For example, at VDAB, recommending which vacancies might be most suitable for a given candidate or job seeker is a very narrowly defined task that AI won't be able to play chess, for example, or solve any other type of problem. Whereas now, with the advent of large language models, that is definitely changing, and we're seeing that AIs are more generally capable of solving a spectrum of tasks. We're not yet at the level of AGI yet, where they would be equivalent or as capable as a human being might be. But we're definitely at an intermediate stage where I would call it something like artificial broad intelligence, something broader than the current than the previous narrow intelligences that we developed. That is the most striking evolution.
And what does that mean? It's getting broader. Does that mean so you can do more with one model? Does that also mean it becomes cheaper? It can do more? What does it mean? Because essentially, if you tell me that, I would say, okay, but then you just had many narrow AIs and you can do the same. What's the advantage? The cost gets lower, or the amount of use cases, the things you can solve gets bigger, or both, or?
There's a few that come to mind. So one is to train a narrow AI. essentially most of the time we're using machine learning, which learns from examples. And to train a narrow AI solution, that means we need many examples of the desired behavior in order to be able to replicate it on unseen data. And that is a bit of a downside of narrow AI, is that to build a new solution, you basically have to collect enough data to be able to train that narrow AI solution for or on. With broader AI, with the capabilities that large language models make possible, we're seeing that a lot of tasks now can be solved zero shot, meaning you don't necessarily need to train a model to solve the task. Instead, you configure or you adapt the existing large language model, the broadly capable model, to solve that task.
So that's a bit what we call the prompt engineering. Like you just give it proper instructions, but it has the knowledge already.
There are several techniques that we use to enhance a base large language model's capabilities to be able to solve the tasks that we want them to solve, without necessarily having to retrain or even fine-tune those large language models. Prompt engineering is definitely an important one, where we instruct the model on how we want the model to behave.
So instruct a model, to put it simple, you just tell it what to do.
We tell it what to do, yeah.
I am a consultant in financial services, and suddenly the model knows I'm working from that context, and that gives it certain abilities.
Right. Telling it what to do is a main way to achieve the ability to solve the task that you want to solve. But there's an array of other techniques that we use to make even more applications possible. Just a few examples are retrieval augmented generation, where you couple a knowledge base to the large language model and you retrieve information from that knowledge base so that the large language model can help answer questions or solve tasks based on the information in that knowledge base.
So that's one of the things, because often people see large language models as both a knowledge base and an interface, but actually it's not really the case, because if you would look at the large language model, the hallucinations also, it's a huge knowledge base, but filled with holes. And we don't know where the holes are. So that's one technique to solve that. It needs to look in a not hallucinated, but factual database, right, of documents, of other things. And then it retrieves it, but based on that information, it then generates new information. And that helps, for instance, with making sure it's correct. Is that one of the things, or?
Yeah, so it helps. I would say retrieval augmented generation addresses several problems, hallucination being one of them. But also the large language model may not even have been trained on the knowledge base or the information in the knowledge base that you have. For example, if you have a knowledge base built up at your company, the large language model was likely not trained on that information. So it doesn't have the information to begin with.
So the main strength of the large language model then is actually being an interface between documents, computer data, to put it a bit conceptually, and human language. And that's what the language model does. It's being the interface in between. Is that correctly put?
It is. It's been said that large language models essentially enable us to program using natural language. So the instruction we talked about earlier is telling it what we want it to do. It's
the best interface between a human and a computer,
yes.
Basically.
I mean, we use natural language to instruct each other. Why don't we use natural language to instruct AI? So that's essentially what we're doing with large language models. And retrieval augmented generation really does solve, or at least address the main concerns that we have, or the drawbacks that large language models currently have with hallucination, with respect to not knowing about information at your company or in the knowledge base that you care about.
So we went from narrow to broader, which basically, if I understood it well, we're saying, okay, you have the foundation models, that's how they're called. They're trained on huge amounts of data, so they have somewhat of a basic knowledge, which allows us to do things with less data. But the quality of the data becomes more important then. Your proprietary data, the ones that you want to use, that's the quality of that data becomes more important, but the amount becomes less important. Is that a right translation?
Yes, because to build those broadly capable systems, essentially we're adapting those broadly capable systems to again solve particular tasks. But to to go through that process, indeed, one of the main differences is that we no longer necessarily need to collect a lot of data to fine-tune the large language model. We can still do that if necessary, but it becomes less of a requirement than it was with...
So it's one of the steps to improve it, but the marginal return is a lot less than it was before.
There is less of a return, and I think there are actions or steps you can take that have a higher return than fine-tuning the large language model at this stage. Indeed, for example, prompting, retrieval, augmented generation.
And that's the case because now going a step deeper in what the possibilities are today, that's the case, for instance, GPT-4, which is, I would say, the main used one, which is the backend of ChatGPT, which is what everybody is talking about mainly. But you also have, for instance, Llama 2 released from Meta, where Microsoft is being the smartest one of them all, because they offer them both. But you have GPT-4, you have Llama 2. Is it the same in the sense that you're saying, because the capabilities of Llama 2 are still not at par with GPT-4, does that mean you need to address it in the same way to get it to a performant level? Do you understand what I mean? So you have, for GPT-4, it's so good that just doing prompt engineering is often sufficient, or giving it a few examples, but also mainly as a prompt. You just say, okay, here are a few examples of what we've done, and you give it, and then it can use it as a context to work from. The fact that Llama 2 is not on par, does it, for instance, make the importance of fine-tuning on your own data more important, or how do you see that? How does that work? Or am I asking a stupid question?
No, I think there are different things at play there. I think the fine-tuning for Llama-based models is very important. We're already seeing many different fine-tuned versions of Llama 2 appearing on Hugging Face, for example. And that is important because they essentially extend or improve the capabilities of the large language model itself. And that is an important direction to take because we're nowhere near the end of the capabilities that those large language models have the potential for.
And can you go a little bit? Because if I recall well, and don't shoot me now, that has something to do also with the chinchilla law, that there's evidence that we're definitely not yet at maximum capabilities.
Right. No, so we've been improving, and when I say we, I mean humanity, let's say as a whole, has been improving large language models with essentially more compute and more data, and also higher quality data. We're not at the end of compute. We're not yet at the end of data. So there is still a lot of headroom to improve the base capabilities of the large language models.
So we'll see a GPT 5, 6, 7, maybe 20.
Yeah. Until we hit a wall, until we do run out of data, or until we do run out of compute.
And is there a theoretical maximum capability? As in, once you even add more data or compute, the marginal returns are just so low that it's no longer relevant?
Well, it depends on what metrics you look at. The returns on some metrics are becoming more marginal, but on other metrics, we're still seeing linear gains with increasing data, with increasing compute. So it's not exactly clear when we'll hit a wall, I would say, but right now it definitely looks like we can keep on continuing to improve the large language models, to improve their capabilities significantly, at least for another year or two, perhaps. And so that, I think, is more important, or will have a higher return on the investment, on the efforts that you put into fine-tuning a large language model on proprietary data, for example. So that's something exciting to look out for.
So I understand it as that you're excited about the evolutions of, so what Meta, Facebook, Zuckerberg is doing, they're releasing open source models. They're giving them actually away for free. So I think it's the first one right now with that capabilities that is a permissive open source, which has a permissive open source license. But there's a case for you need to put more data into it to get it on par. Is that how I should understand it?
Well, Meta, with the release of Llama 2, have approximated the quality of ChatGPT or GPT 3.5. which is not yet at the level of GPT-4. It is approximately as capable, but on some metrics, it is not yet equal to GPT 3.5. For example, its coding abilities are less strong than GPT 3.5's. Also, its alignment seems to be overly restrictive.
Maybe just to clarify, so coding, why is that important? Because that's one of the things where people even say that we're already at GPT-5 because GPT-4 with code interpreter is so good at coding, enabling a huge amount of new capabilities. That's one thing. And then the other one, alignment. What is alignment? Alignment, is that the alignment that OpenAI has coined with alignment with our norms and values? Is that what you mean? Or, yeah.
So coding, I would say, is probably one of the most important skills that a large language model has because it enables so many other applications once your large language model is good at coding. And indeed, alignment refers...
Can you give an example why that is?
So once you can get a large language model to write high quality code, essentially you can think of code as a more structured, a more simple version of natural language. Natural language is quite complex. There's a lot of ambiguity in how we communicate. There are a lot of rules to how natural language works.
So you would be happy if Neuralink breaks through, which is, if I remember well, Musk once said, the reason he founded Neuralink is because natural language is so inefficient in communication and so hard to understand that if you can communicate from brain to brain, that would solve a lot of issues.
Yeah.
Rabbit hole, sorry.
Yeah. So natural language is just, it's a very complex thing and a very inefficient way to communicate. Whereas code is much more structured. It has much simpler rules that you need to satisfy to speak code, so to speak. So in a way, it's easier to learn. And also, because it's so well defined, it's easy to run that code and produce results with that code. And that opens up a lot of really interesting possibilities, because what you can do is you can ask the large language model, can you write a program that does this, then actually execute it and see the results, and that opens up a whole new world of capabilities.
So that is then coming back to what we said before. Large language models are the interface to computers. Well, large language models that can code well, those are the interface, because they can instruct a machine as we want it to.
We can basically tell a large language model, this is what I want you to do. And instead of the large language model magically trying to solve that task, it might go ahead and write code to solve that task, execute that code, and then come back with the results.
So hearing that, does that also mean, because there's a huge discussion on, can we fix hallucinations? And do we have to fix it? If I hear that, I'm like, maybe we should just focus on it being the best interface and not trying to know things, but just find things, which is a different way of solving it.
I think hallucinations are maybe made out to be a bigger problem than they really are. It's true that they hallucinate, but I think that's mostly people that complain about hallucination, that they just have, let's say, mismatched expectations. Our own memory, for example, is also faulty. If I ask you to recall some facts about history, you also...
Try me.
Well, I'm not going to try you. I guess the difference is you wouldn't make up a fact and present it as a fact. You would be honest about the fact that you're not exactly sure about it.
Yeah, but that's very interesting that you're saying that, because what you told me a few weeks ago is that actually a large language model is more or less capable in knowing. It has a probability. So the hallucinations are, if I understood it well, correlated with a lower probability.
Yeah, I do believe we could get large language models to basically caution or explain that they're not exactly sure about the things that they're telling you, as a human might do, and that you could consider that part of alignment, for example. Which is the other topic we were just discussing.
And alignment, again, so that's aligning with our norms and values. That's how I understand it.
Norms and values, indeed. But also, it's also a bit about safety. But you could classify that as norms and values.
And you're saying Llama 2 is not on par yet, or can you give an example where it's not aligned, or what does that mean? It's not as good in alignment?
Well, not as there are several dimensions on which it can be less good in terms of alignments. One aspect is if you're asking a harmless question, you would like it to not censor itself. You would like it to come back with a useful answer. And that's one area where Llama 2 currently is over censoring itself in an attempt to be safe and harmless.
So it doesn't really figure out yet when is it going over the line and not. So they've made the line very broad or something.
It overfitted on how cautious it needs to be.
Yeah. And do you have an example on that, or?
Not off the top of my head, but asking essentially a basic question, you might get a response that says something like, "Hey, I'm sorry, I can't help you with that. It's important to be, to consider the feelings of this or that person, even though you're just asking about facts."
For instance, if I would have a picture, if it's multimodal, and I ask how many black marbles, and just because it's black versus white, for instance, that could trigger something.
It's cases
as an
like
example.
That, but even less contrived examples, even basic questions can trigger the let's say self-censorship. Yeah.
So we've been going from narrow to broad. We have a bit of, because that's essentially what's happening a lot today, or the things that are happening are closed source versus open source, and then you have regulators now coming in, which is also a huge challenge and could potentially be very harmful, actually, even for innovation. But before we go in there, so we have Llama, we have GPT-4. How do you see this in the next few months evolving? Because I recall in, I think, November last year, we were discussing GPT-3 and what will be happening. And we were trying to predict the future in terms of when will this actually break through. And we said, end 23, something like that. I recall that we said that something breakthrough could happen. And suddenly a month later, we didn't expect it. It was there. How do you see that now? Do you think we'll go in the big strides that'll continue? So I'll give also one example, which is one I think is underrated. BART, for instance, already has multimodality in it. You can already send pictures to it, but it didn't make a big fuzz, and it didn't make a huge, at least not in the news. Is that because it's less important, or is that because it's underestimated? And how do you think this will continue?
So I think we're probably going to see a few big leaps still in the coming months, maybe a year or a few years, including multimodality. That's definitely going to be another large leap. Probably by the end of the year, we'll see GPT-4's multimodal capabilities. Another leap I expect will be related to the concept of agents, and having large language models not just produce text, but also take actions on behalf of the user, either to retrieve information.
Which is something we can already do?
Yeah, we can already do it today.
But why do you see it changing? Or what is it, because it's not on a it's still not good enough? Or why do you say that?
It's right now. So what we can do today is we can have large language models. We can essentially give it a list of functions and describe those functions to the large language model and say, hey, if you want, or if you need to, or if you think it's useful, you can call any of these functions in order to
and
help the user.
And a function could be retrieve information on my Google Drive, or use this calculator, or it's basically any digital tool or computer tool that it can get access to?
A function is, you can think of APIs. Any API could be considered as a function.
So anything which a computer can talk to, yes, it can use as a function.
A classic example might be to look up the weather given a location. Yeah. So if I ask GPT-4, hey, can you tell me what the weather is like in Boston? And I tell it that it's able to call a function to get the weather at a given location, then it might decide not to respond to my question because it doesn't actually know what the weather is like in Boston right now, but instead to call a function. And then once it has seen the output of that function call, then it can formulate an answer. Mm-hmm. This is a very basic functionality that enables the concept of agents, where agents can string together multiple functions to arrive at a result. But it's still early stages, I would say. I think we're going to see...
And the way you describe it is mainly as getting information, but it's not as putting an action out there.
No, it could also be either retrieving information or taking actions on your behalf. For example, sending an email.
So that's already possible today, but we're still exploiting that, and it's still unclear how far the capabilities will reach. Is that the point?
I would say we already have the functionality where we can get large language models to call functions and to perform useful actions as part of the interaction that you have with a large language model. But I wouldn't call that necessarily an agent yet, where an agent would be like a narrow version of AGI, perhaps, an agent that is capable of...
Our first level of AGI.
It could be a first level of AGI where the agent is... you could maybe compare with a human that is trained to solve certain tasks using a set of tools that you give the large language model. And that it's able to not just call a single function like, hey, what's the weather in Boston, for example, but that it's able to string together different functions in order to accomplish a wider spectrum of tasks within the context that it's applied.
So it's a bit, if I put it very simple, the if this, then that. If you know that app, but then very, very smart, and you don't have to per se program everything yourself.
Yeah, you don't have to say if this or then.
I'm thinking of, I would say, a large language model, make sure that when I come home that the house is and the temperature I like, and that the garage is open based on my GPS. Just make sure if I come home that I can come home in comfort, and it will do the rest. Talking to the weather app, to my garage port if it's linked to the internet, and all of those things, and it will just do it like that for me.
Exactly.
So we're having Jarvis.
It's something, I would say something like Jarvis, yes. I wouldn't call that AGI yet, but I think that's an evolution I expect is likely to actually occur, is that we will see companies having access to their own personal Jarvises that are equipped with tools or functions, if you will, to execute and to look up information or to take actions on the user's behalf. And
that easily begs the question, where will it then go wrong? Seeing the fuzz online, or in the news or in the media on AI will kill us, Terminator is going to happen. I know how we look at it, but still, if you get an agent and it can do whatever, it could, if I come home, shut the garage on my head, just putting it in an extreme, but why wouldn't that happen? Why don't you're not scared of it at all? You're even thinking it's ridiculous to put it like that. Why? And why don't you see that risk? Or why are we exaggerating? Or
I think it's important to distinguish between near-term risks and longer-term risks.
And can you define near and long? Because for most people, 3 years might be long, but I don't think you're talking about 3 years with long.
Let's say on the order of 2, 3, 4, maybe 5 years.
Is the long horizon?
No, that's the near. That's the near horizon. Okay. Yeah,
and the long one is 10, 20 years.
Yeah, let's say that's maybe 10 plus years out. Yeah, and on the near term, currently, and this is my own opinion, of course. I don't speak for others, but I don't see huge near-term risks. At least not existentially, on the existential level. It's an interesting debate to think about. It's like a thought experiment. Like, could it ever happen? On the longer term, it's impossible to rule out. It's impossible to say that the chance of the probability of that happening is 0. On the other hand, even on the longer term, I don't expect that to be a likely scenario. That doesn't mean we shouldn't talk about it. We shouldn't consider the possibility. I do think we could consider the possibility and think about its implications. But I don't think the threat is the probability is sufficiently large to merit discussing that or taking that more seriously than, for example, climate change or war or things like that.
And why do you believe that? So you're dissecting risk into probability and impact. The impact is existential, so there's no, but you just think the chance of it happening is extremely low?
I mean, if I tell you that tomorrow aliens will visit Earth and will wipe us out, is the probability of that happening zero? It's also not zero, but I guess everyone would agree that it's sufficiently low that we don't need to consider that as a real probability or take the threat seriously. AI being an existential threat is on a similar level to me at this stage, yes.
But how would you comfort someone who is scared of that? Why? Because, so for me, I'll give what I think about it. If I look at AI today, it's coming back to the beginning of the conversation. It's a matrix or a tensor, if you will, of numbers, and you need to put numbers in. You need to give it electricity, a GPU, and there are numbers coming out. Basically, that's on the technical level what it does. Numbers in, numbers out. Stop.
Exactly. Yep.
Full stop.
Yep.
That does make me really scared, because the numbers going in are the ones we're putting in, so we're in control over there, and the numbers getting out, well, they're numbers. If we put a halt to what those numbers can do, it stops. And then there's others saying, yeah, but maybe it goes so fast, it gets control over even production of GPUs, and it can do it, and it doesn't need us, we can't stop it anymore. Even if that would be the case, which is extremely impossible, but even if that would be the case, there's not enough resources on the planet to build enough GPUs, to give enough power even to AI to be that powerful. It's not possible today, simply in terms of resources. That's how I look at it. Is that in a similar way that you're saying, okay, that's why I don't think it's even likely, but that would mean quantum computing, if it breaks through, and in what way, then we might need to reconsider? To put it, I'm trying to put it in a bit of a...
No, I think those are some good points. I also agree with the idea that it's not sufficient to have an intelligent entity, let's say. It also needs to be able to affect reality. If it's just an information system, it won't be able to affect reality other than through interacting with humans that consume or produce that information. So that, I think, is one reason that I don't think we need to take or consider that as having a high probability, that existential threats. Another one is that, as far as we can tell, what we're creating with large language models is not equivalent to a human being. It has characteristics of humans in that it has cognitive abilities, and those cognitive abilities are impressive, but it lacks a lot of other qualia that make our existence as humans unique. It does not have a conscience, for example. It doesn't have will. It doesn't have sentience. The only thing that we're replicating today is the cognitive abilities that we have as humans. And so if a large language model or future derivatives thereof don't have a will, aren't necessarily seeking out to accomplish a goal, that also, again, reduces the probability of an existential threat significantly to me. That's another factor.
And so, but that's on the level of existential, of AGI, and I think you and I at least both agree that we don't see that happening. But if I were an enterprise and I want to try out this technology which gets some form of autonomy, because you need to give it some form of autonomy to be able to really make that impressive capabilities like Jarvis, how do I control that? How do I manage that? Because I don't want something to talk to clients and say stupid things or whatever. That's one of the reasons, for instance, why when we started with large language models, the first cases we advised clients, don't let it interact with your customers yet. Keep it internal so that you can experiment and learn what works and what doesn't, what the boundaries are. How would you see that for the agents? So because the amount of value being created with agents is probably a factor or an order of magnitude higher than what large language models are doing today.
I like Steve Jobs' analogy there, where AI and software is like a bicycle for the mind. I won't repeat the full analogy, but essentially his point is that as humans, we're not necessarily very efficient, energy efficient in moving ourselves from A to B compared to certain animals. But once you give a human a tool, like a bicycle, we become much more efficient than any animal can move itself from A to B. And that's for physical movements. But the same can be said of enhancing our cognitive abilities. AI in that sense could be a bicycle for the mind, and that we can accelerate our own outputs using large language models, using agents based on large language models. So the way to address that, in my opinion, is a couple of things. First of all, it wouldn't be an agent that is fully autonomous. I would still have humans basically confirm that the actions that the agents suggest. So, for example, if an agent wants to send an email, it might write the draft for you, but it won't actually send it. It's still up to the human to hit the send button.
So, but that's also a way then the accountability remains with a human. You wouldn't give the accountability to the system.
But it is a bicycle because the human didn't actually have to write the email. They would only have to verify that the email is as it was intended. So that's one thing, and the other thing is don't give it access to actions that could be dangerous. It's like you don't
give it access to a paperclip machine.
Yeah, don't. You wouldn't give humans access to the nuclear football either. It's just you don't do that. You restrict the access to dangerous things, and I would do the same for agents based on large language models.
So the functions that you were saying, we describe which they are. Those determine the actions that they can do, and that we need to limit.
At least limit the ones where you think there might be damage if the agent would take an action that is inappropriate or.
But so there is what you're also saying with that. There is a possibility that it would do things which were not predictable.
Yes, it would, and it could cause damage. But I would say that is not because of ill intent, because it has a will, but rather because it made a mistake. Humans can make mistakes as well, and so can agents based on large language models.
But that also means, if I would translate that in how AI is evolving and how humans evolve, those mistakes will likely occur less and less if you use it. So giving the system more confidence and being able to give it a bit more autonomy over time.
I think so. I think as the large language models become more capable, I do think we'll see a shift towards giving them more autonomy because we trust them more and more over time.
So that's one of the big challenges. Another one. So we were talking about how do we see this evolve. You say agents is one of the first steps there. How, do you see something in the next 2 years happening? Another big stride. Because I recall, so we talked about how do we go from large language models today, for instance, to more AGI. And I don't want to go back to AGI again. But you described a few concepts or things that it should be capable of. Do you see, so first those concepts maybe, and then do you see these happening in the next few years, or are we just very far away? And let me give an example. One of the things that OpenAI has done, they've hired the guy who made the poker machine. I don't know how it's called again. I don't know if you. I don't recall his name, but his main strength was building reasoning systems, and that's why OpenAI hired them, because one of the things that large language models are not good at yet, or not good enough, is reasoning. Is that then, because that's a clear sign that they're also working towards that? Is that what you would say that would be a next big leap? Or do you see something else?
I mean, the ones that we're sure of are agents, multimodality. Those are definitely ones that are coming. There are certainly a number of challenges remaining still that scaling may not solve by itself. And reasoning.
Scaling, you mean compute and data, more compute, more data. Yeah. But even then, it would probably not emerge enough intelligence from that.
It's difficult to say. It's really, I find it's been incredibly interesting to observe the reasoning capabilities that GPT does have, to see those emerge from the objective function that large language models have, which is simply to predict the next word. I don't think many people could have predicted that predicting the next word could actually result in that type of emergent reasoning capability. That's been spectacular to witness.
So the objective function, in more layman terms, that means what it has to optimize for, what it should be best at. It's predicting the next word in the whole vocabulary of the world, basically. That's what GPT-4 is trained on. Vocabulary, not vocabulary, but text corpus in the world.
I find it extremely interesting that such a simple objective function could lead to such interesting behavior. Simply saying, I want to predict the next word, and throwing a lot of data at it, or throwing a lot of examples of what the next word should be, apparently it turns out is sufficient to create those emergent capabilities, such as limited forms of reasoning. And that, to me, is pretty fascinating. In a way, in hindsight, it does make sense, because if I give you a logic puzzle, and I've shared some with you in the past, for example, a game console and a game together, they cost 550 euros. The console costs 500 euros more than the game. How much does the game cost? I won't spoil the answer, but it's not 50 euros. To be able to predict...
And don't Google it.
To be able to predict the next token there, or the next word, which might be the answer to that riddle, the large language model essentially has to evolve some form of reasoning to be able to figure out what the right token or what the right answer might be. So it is incentivized to actually develop reasoning capabilities, even though we're only asking it to predict the next word or the next token. That I think is really interesting. Although we're not asking for it explicitly. We're not asking the large language model to explicitly develop a reasoning capability. And I think that might be indeed one of the next leaps, not necessarily in the next year or two, but maybe beyond that we start to explicitly incentivize large language models to develop reasoning capabilities on top of the existing objective of predicting the next token.
So pushing it back to, if you could put it in physics terms, like the first principles, that they need to think from the core elements and not of just intuition. As they have to build up a reasoning for everything they would spell out. Is that what you mean?
Yeah. So I would say there are several things that don't feel quite right with large language models. One thing is, for example, they don't have the ability to have an internal dialogue. So there is no way for it to take some time to think before it produces an answer.
The chain of thought, isn't that a bit?
Yeah, that's a way to ameliorate that problem. Chain of thoughts, for the audience, essentially means asking the large language model to think step by step. And because it's thinking step by step, you're giving it more space, more floating point operations to produce a correct result. It's a way of externalizing what we might do in internal thoughts.
It is a bit the difference between system 1 and system 2 thinking. It needs to take
you're
time to really use its knowledge. You're
asking it explicitly to use or to emulate a form of system 2 thinking, slow, reasoned
you're
thinking.
Picking emulate, you're picking the words as in it's not really doing that according to...
Well, it wasn't built to reason necessarily, but it's mimicking reasoning. It's mimicking, when we ask it to think step by step or to take steps, several steps before it produces an actual answer to the problem, it's mimicking what it has observed in the training data.
But are we built to reason? Is that we're built to survive?
I do think there's a difference.
Is that not something that emerges from the fact that we learn if we reason, sometimes it helps us to survive? Now it's getting very philosophical.
Yeah.
Let's maybe not dive into that, but
I think there's a difference between a human mimicking reasoning capabilities and a human with actual reasoning capabilities. And what I think we're observing with large language models is the former situation where the large language model is mimicking a reasoning capability without necessarily having a true reasoning capability. And I think a component in that makes the reasoning capability in humans unique is that we have a way to evaluate the things that we say, that the actions that we take, whereas a large language model cannot easily go back and evaluate the things it has already said.
We put out a hypothesis, we do some testing, basically. We look at the facts and then we combine that with the hypothesis. That's something we're very good at.
Yeah. If you're, whether it's writing an email or working on proving a theorem, you take steps towards your goal. And then with our system 2 thinking, in my opinion, or in my belief, we evaluate those steps and go back and edit them or improve them with new ideas that we come up with. And that is not something that a large language model is capable of. It isn't capable of evaluating its own steps, and it isn't capable of hitting backspace and deleting those words and then rewriting them with an improved version. It will just produce tokens, and it cannot wipe those out once it realizes that it's wrong.
So what you're saying is that we will need a next breakthrough or something, or you feel that there's more to gain in that reasoning, and that's probably the next big leap if we find a solution for that. But the way we're going to do it might be really the emerging capabilities of LLMs or finding another way.
I think we're on a trajectory to developing AGI, and although it's speculative, I don't believe full reasoning capability to emerge as it does or as it exists in humans just by further scaling up the data and scaling up the compute. So I do think we need to explicitly incentivize developing a reasoning capability. That's personal opinion, of course. It may turn out to be the fact that it does, in fact, emerge from predicting the next token. But yeah, so I think that's something that we'll probably see beyond the next two or 3 years. Maybe it'll take a bit longer than.
So multimodality agents and basically a next form of agents which are more capable at reasoning. That's a bit.
Yeah, I think those are the things that I think are quite likely to happen. Where we So I'm now working in a company. We're not using AI yet, but I hear we're going to use AI, and I hear those words that there will be agents doing things autonomously, and they might even get reasoning capabilities which are quite elaborate. Should I fear my job? I don't think so, or not in general. It could turn out to be that some jobs might disappear. But in general, I think most jobs or most people will still be doing jobs, still be producing value in the economy.
So I'm trying to unravel what you're saying, where there will be equal amount or maybe even more jobs, but they might change. They will change.
I think what we do in the work that we do will change because of large language models, especially in any job that requires cognitive work to be done. There, I think we'll all have access to agents or co-pilots or whatever you want to call them that act as or that enable us to have bicycles for the mind, essentially, to enable us to do more work in less time. And increasing the amount of work we can get done in the same amount of time means that we can lower the costs. And there is a fallacy there that lowering the costs or achieving this might mean that we just have less work to do in general. But I believe that if you are able to lower the costs, actually the demand will increase. And there isn't a fixed amount of demand for the output that we can generate.
So we'll get some form of superabundance then.
We'll just be able to produce more collectively.
So we'll be able to use lawyers just if we have a small issue. Because today you're not using a lawyer if you have a small issue in your contract because you just think it's too expensive to do this. So I'll just leave it or try to figure it out my own way. Then it will be as affordable because of the support. Like we have henchmen supporting lawyers. If they become more affordable through that technology, we might use it for everything.
If it becomes more affordable, because people can interact with, let's say, lawyer agents themselves, or because the lawyers are using LLMs to be more efficient, it just becomes more affordable to everyone, meaning the demand for legal services will increase. It's not that there is a fixed amount of demand for most services. I think the more you can get, the more you want. And as a result of that, I think we'll just be more productive overall. And in general, I think large language models will essentially enable a higher standard of living, enable more prosperity by increasing economic output.
So you're saying jobs won't disappear, they will, well, some might disappear, but they will be replaced by others and they will change?
I think in isolated instances, there might be some jobs that are fully redundant, but in most cases, I think that it's a way to increase productivity, and that increasing productivity reduces costs, and that reducing costs increases demand.
So, and those people will then flow into other jobs, basically.
You can just get more done, and so more people will.
We can even look at it from another angle, I would say. If you look at the demographics, we need more productivity, or we won't be able to sustain our economy. Yeah. We won't be able to sustain our welfare if we don't get a new level of productivity. It's a necessity. Looking at it from another angle, but so. Maybe to wrap up that point, because one of the quotes that you see, it's a bit cringy even maybe, is the people who AI won't replace people, but the people who use AI will replace the people who don't use AI. That's basically also what you're saying then.
I also think that's true. If you're competing with other companies that are using AI and are therefore way more productive and can offer the same services at a lower cost, yes, then I think those companies will disappear.
That's a very interesting point you're making, because I don't know if you read the book Good to Great, which is like one of the bestsellers in how to build a great company, blah, 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 blah. It's a good book, by the way. But one of the things that they talk about is that technology should be an accelerator and not a... It's only something you should use to accelerate something you know you're doing good already. And that also entails that you shouldn't use all technologies, just the ones that are good for what you are trying to do. But the way you're putting it sounds to me that AI will be good for every company.
Well, most companies, yes. I'm trying to think of if there are companies for which it might not be useful. Maybe in manufacturing, it'll be less useful in the actual manufacturing itself. But for...
Why would that be? Looking at RT2, for instance, now the evolution of Google in robots being almost autonomous already. Okay, it's far from being good. It's too slow. The performance is not there yet. But do that times 10 and we get close to something which would be very interesting in physical production.
I would say, yeah, it depends on how you define manufacturing or on what timeline you're looking at it. I would say any company that has information systems or uses language to interact or to discuss what to do next, that large language models will be useful. So I think that's pretty much most of them, yeah.
Yeah, but so for manufacturing, you meant the physical manufacturing, it will take more years, but it will come.
Yeah, I think it won't be until we are able to embed large language models into robots before that, physical labor will start to see the effects.
But so RT2 is not good enough. That's what you're also saying then.
I'm not familiar with RT2.
I'm saying the wrong word then, RT2, the one Google. So they released a new model it's a large language model who can operate a robot arm.
Oh yeah, I think I've seen it. I wasn't familiar with the name. No, that is an interesting example. But yeah, we need to get to that point first where we have robots that you can interact with using large language models. And I was referring to actual physical labor executed by humans, not by robots. Yeah.
So that gives me a bit of room to go to the one thing that I really wanted to ask you as well is I would almost call it your famous tweet on the fact that we might not be as smart as we think we are. I think it was a very interesting tweet. I think the media found it very interesting as well. And I think it's still a very good question. Do you still stand behind it? And how do you see that moving forward?
Yeah. So for context, in beginning of November last year, I tweeted something to the effect of,
or X'd something. I don't know what we have to say today.
I guess now it's X'd. Yeah, I'm not sure how to pronounce it. Yeah.
Okay.
Tweeted something or X'd something to the effect of that perhaps we might not be as impressed with AGI as that we might be disappointed with our own cognitive abilities, with what's necessary to replicate our own cognitive abilities. And I think with the launch of ChatGPT, I think many people have considered, well, if our cognitive abilities are seemingly so easy to replicate using next word prediction, what does that say about our own intelligence? Perhaps it's not as special as we may have thought implicitly. So, yeah, that's something indeed I still kind of, or I'm still processing what that might mean or how that could work. I do think that
so basically what you were saying is, if you just look at, coming back to what you said before, the one qualia or the one thing that the cognitive ability, that not might be as impressive actually as we often think. That
Exactly. We tend to think of ourselves as humans, our cognitive abilities as being, I would say, very special, unique, especially because if you compare in the rest of the world, there is nothing that comes close. There is no other species with an intelligence equal to that of humans. We're so far beyond any other living creature in terms of intelligence. It's just not even comparable anymore. And so maybe it feels a bit like magic almost that we're able to communicate in this way, that we are as intelligent as we are. I think some people with large language models, with the advent of large language models, have this feeling of, maybe that intelligence isn't as special or as unique as we once thought it was, and maybe it isn't as difficult to produce intelligence, to reproduce intelligence as that we might have thought, which, if true, means that we're actually much closer to AGI than we would have thought 5 years ago, for example. Which is at the same time...
But then you define AGI not as something that has autonomy or agency, but something that has just the cognitive ability similar to a human.
Exactly, just purely replicating our intelligence, that qualia of our existence, the intelligence component, without the will, without the conscience, without the sentience.
And not even, AGI would not even mean the scalable super intelligence that some people already say. It's just
human level.
In one system you can have the cognitive ability of one human, basically.
Exactly, yeah. It might not be as far away as we once thought it was, because it simply isn't as complex as we once thought it was. That was kind of the thought there, which, as some other people have pointed out, perhaps comes across as somewhat hubristic, that we can actually create an equal to our own intelligence. But I'd like to counter that in a way where I say, perhaps it's hubristic to think we cannot replicate our own intelligence, because why should we be so special?
Future will tell. I think that's something we don't know yet, but it's definitely exciting to see what will happen and how this will move forward. Maybe to wrap up then, because once that would happen, AGI, and ones that maybe would accelerate, you hear a lot of, if you talk today with people, I often hear two things. It's utopia or dystopia, and usually you're in one camp or you're in the other. I'm pretty sure you're in some form of utopia, but if you would have to make a prediction for both, what would be your dystopian future and your utopian future? And let's start with the dystopian future.
In the sense of what I think is a realistic dystopian outcome? The most realistic?
Yeah, good question. For me, you can go, if you go crazy, then everybody knows what crazy would be, I guess, Terminator, and we would get all killed by machines. Let's indeed give a scenario where you think if things go wrong, but it's likely to happen.
Okay. If things go wrong, I don't think it'll be AGI that destroys us. I think it'll be humans that destroy us with AGI. That's my feeling. So our dear friend in Russia getting the hang of AGI and just suddenly saying, I'll not just try and take one country, but I'll try and take the world. Something like that. Yeah, I think it's going to be, if it does happen, which I hope it doesn't, and I also don't believe it's likely, but if it does happen, I believe it would rather be, not rather, but I would think it's more probable that it would be humans using or abusing AGI to destroy humans.
And do we then need to make sure he doesn't get the hang of that technology, or do you see a solution?
I'm not sure what the solution would be, to be honest. It's also not something I think we should spend time on until it actually becomes a problem. And I think that's more for like international politics and it's a bit outside of my...
Yeah, maybe that's a bit... and also quite a big hole if we dive into that. But okay, so your dystopian future is bad actors get access to AGI, and maybe if I would translate that, they get access to it sooner than we do, saying that, implying that we are the good actors in the West. So, or people with good intentions. So what you're saying is that that's dystopian future. Bad actors get access to AGI sooner.
I mean, it's the most likely of the dystopian outcomes. I don't think the scenario where AGI turns into Terminator robots that want to destroy humanity. I think that's the least likely scenario. I think that's probably less likely than aliens landing on Earth, to be honest.
And Elon Musk believes we're in a simulation. So, utopian future.
Utopian future, which...
And you can also give a realistic one, not one where everything will be perfect.
Well, I definitely... What I do think will happen is that everyone will get access to a personal Jarvis, the Iron Man Jarvis. I do think that is something that is likely to happen, both in the sense of having an oracle that can tell you anything you want to know, but also in the sense of the Jarvis able to take actions on your behalf to solve problems, to help you with things. And I think that is going to be extremely useful, extremely helpful to many people, because you're making so many things accessible on such a wide spectrum to so many people, that is definitely a utopia or a utopian future to look forward to.
So what you're saying is that we'll see actually us putting in stuff in computers move away. So it will be, if I hear that, I'm thinking of an evolution which goes from today we have to type, we have to do whatever to put information in computers, and what we get out is even hardly good often. That will move to we just talk to something in our ear or wherever around us. That will translate it into computer actions, and then it will come back with an answer, or it will do what we want it to do.
Anything you need help with, especially in education, for example, I think that could have a huge impact on giving everyone access to a personal tutor to really teach you, to help you learn things that you're struggling with, for example. That's on the realistic front.
But so do you also think then that what I'm then automatically thinking about is, so I have a smartwatch with it looks at your heart rate and your all of those numbers, and you can go a lot further already with more advanced watches. But you have those data on your body, and then you can say, okay, Jarvis, how good am I? What should I do? What should I eat? So that's the point where we're moving to, where Jarvis is the interface. Of course, you'll need other evolutions, as in measuring certain things in your blood, but those things combined will really go to the future where we can go in very personalized medicine and actually predictive or prescriptive healthcare on a personal level.
I think that is not only possible, but likely to happen. Because it's already...
Next year? 2 years?
No, maybe not in a year or so, but maybe it'll take a few years to get there. But those are things that are not impossible to achieve with the technology we have today. So it's basically just a matter of time. What is less likely, but what I do hope will happen, is that we will at some point be able to realize large language models that are equal to the best of the humans that we have in various domains.
With the best, you mean having being very intelligent, and I'm sensing here being able to do research.
Exactly.
Yeah.
We need the best people to be able to make progress on developing LLMs. Right now, we can't use LLMs to develop LLMs because they're simply not equal to the humans that are developing those LLMs. But it's not just LLMs. You could apply it to any other domain that we're interested in, whether it's space travel or nuclear fusion or quantum computing. Once we have large language models or AGI that is at the level of the best of us as humans, then I think we can employ them as colleagues. Even generates 1,000 of them all doing research on improving quantum computing, for example.
All right. And I think on that note, we can close. Thank you, Laurent. It was very interesting. Thank you for listening. If you want to hear more, don't hesitate to subscribe on your favorite podcast platform for the next episodes of Future Forward, where we'll be unraveling the AI future, one expert at a time.